Well, hello there. This is the new video for lesson 10.7. Notice that we did skip lesson 10.6. We're going to talk a little bit. 10.6 was about finding the surface area of pointy things. So by that I'm talking about cones and pyramids. The formulas are a lot more complicated and not as useful as doing the surface areas and the volumes of cylinders and prisms. So we're going to go ahead and that's what we're going to be talking about today. We're going to be talking about volumes of prisms and cylinders. So this is going to pick up right where we left off on 10.5. On 10.5 we did surface area of prisms and cylinders. And really any kind of cylindric surface. We talked about the amoeba one. Today we're going to talk about the volume. And actually what we're going to be talking about today will apply to cylinders, it'll apply to prisms, and it will also apply to that weird cylindric surface that we got from doing the amoeba just like before. Alright, so let's talk a little bit about volume. The first thing that we need to remember about volume is that when we're measuring volume, we're going to measure it in cubic inches, or cubic units. Okay, so no longer are we measuring length units, which are things like centimeters and inches and meters, nor are we measuring square units, which is what we use to measure area. That's what we saw in the surface area questions. All of our questions should have ended with a label. All of our answers should have had a label. We don't want any naked numbers. And that label should have been some sort of unit squared. In fact, if we didn't even know what the unit was, we would just say units squared. So, okay, so first off, volume is measured in cubic units. And reason for that is as we're doing volume, picture something made out of little wooden cubes. Okay, so suppose I stacked up a whole bunch of little wooden cubes, 5 blocks by 4 blocks, and I stacked it 4 blocks high. What we're talking about when we talk about volume is how many cubic blocks it takes to fill up the total three-dimensional volume. We're not just talking about the surface, we're talking about actual physical three-dimensional blocks that you would have to literally fill in. And it doesn't take a lot to convince yourself. Just think about how many cubic feet it would take to make a cubic yard. So imagine a cubic yard. It would be like a big box, kind of like the box that a dishwasher or maybe a washing machine would come in. So picture a nice big box that's 1 yard by 1 yard by 1 yard. And think about, I'm not gonna put the answer here. This is a good thing for the daily quiz tomorrow. Think about how many cubic feet, little cube boxes it would take to fill up that total volume. All right, so that's what we're talking about. We're talking about volume. And it's actually, let's back up for a second here. The formula for volume of one of these cylindric surfaces is very, very simple. The formula is going to be V equals capital B times H. Okay, and just like yesterday, the capital B, since it's a capital letter, it represents the area of the base. And the height represents just what you think it would. It's the height. Okay, so let's take a prism as an example. And this is a triangular prism. Don't forget, prisms are always named, or like prisms and pyramids, oh, excuse me, are always named for their bases. Now see, there's one of those little tidbits that I could squeeze into the daily quiz tomorrow. What happened to Mr. Gunn when he was talking about triangular prisms? He let out a huge sneeze. Alright, this is a triangular prism, and again, remember, it's the ends that are really the bases. Okay? So the ends, in this case, are triangles. Alright, so let's use that formula. And actually, I think what you're going to find is that volume is actually, we think, since it's 3 dimensions, it might be more complicated. It's not. It's actually easier than doing surface area. By the way, it's going to be very helpful if I make these triangles right triangles. And it's a little hard to see my sides here, so I'm going to put little lines in to indicate that that's a right angle. So when I'm doing the base area, that's going to be the area of the triangle. And so because the 4 and the 3 are perpendicular, that's going to be my base. And so the base area, if I break this down, is 1/2 base times height, little b, notice this time, and it's a different h too. I didn't make it look any different, but this h and this h are not the same h's. Okay, this is the height in the triangle. So the 3 and the 4, 1/2 of 4 times 3 is 12, half of that is 6, and so we get 6. And unlike surface area, we don't need to double it, so we do want to keep the 1/2 around. Okay, so now the volume is equal to the base area, which is 6, times the height, which is 10. That's it. Equals 60 I never did say what the units are, so we're going to say units cubed. That's it. That's the whole problem. That's my answer. Not bad, eh? All right, let's try another one. That was a triangular prism, so let's do a cylinder. So suppose you had a big water tank, like the one that's down the street on Lane Allen Road, and let's say it's 20 meters diameter and it's 10 meters tall. Okay, one of those big water tanks that municipalities have. All right, so let's remember that the volume formula, we're always going to start with the formulas, is capital B times H. And again, the capital B represents the area of the base. I'm going to write this one out since it is a circle. It's going to be pi r squared. Don't forget that we have to figure out what the actual radius is. So if the diameter, which is what this is 20, then it's actually going to be a radius of 10 squared. So the base is going to be 100 pi, and this one, we do know the unit, it's meters squared. All right, now take the volume, plug that in for the base area. So the base is 100 pi. And we're going to multiply that by the height, which is 10 meters. That's it. We're done. And so we get 1,000 times pi meters to the third power. And we can do that without a calculator, because if I use 3.14 for pi, I'm going to get 3,140 meters cubed. And the only thing I should probably fix, since I use 3.14 for pi, and we know that's not exact, we probably should put a wavy equals right there, because this is actually an approximation. But there we go. That is the volume of a cylinder. That's really it, guys. There's your formula. It's base area times height. Same exact base area that we had in lateral area, or in surface area formulas. It is the area of the base. Just remember that the base doesn't mean the bottom. In this case, the base was the triangular end, so just be careful about that. This is the gnome that welcomes you to my room, saying that's all. Thank you for watching my newest video, and apologies to anybody who wanted to be in the video, but I needed to get this up and get it uploaded so that people could watch it. So thanks for watching. We'll practice these tomorrow in class. Make sure you finish your classwork, and we're getting really close to the end, guys, so let's just really give it our all. All right, thanks again. Talk to you tomorrow. See you in class.